Imagine forcing an artificial intelligence to read, to comprehend, and to memorize an entire library in a single second. To understand why that task is currently impossible, we have to look back at the design that powers today's AI, Google's 2017 Transformer architecture. When asking a chatbot a question, how does it know which words relate to each other? Transformers use a mechanism called attention, allowing the system to look at every single word in your prompt simultaneously. That single engineering choice made high-level language comprehension possible and led directly to the creation of tools like ChatGPT. But there is a ceiling to this approach. What happens when you stop asking for short answers and instead feed the AI massive legal documents or millions of lines of code? This is the quadratic bottleneck. Because attention requires every word to be compared against every other word, the processing power required quadruples every time you double the document's length. At a scale of 1 million words, the computational cost becomes unsustainable. If AI is to handle larger workloads, the architecture itself has to be rebuilt. One potential solution is the State Space Model, often called Mamba. The goal is to see if an AI can understand text without constantly looking backward at every past word. Unlike attention, Mamba uses linear memory compression. It updates its understanding of a sentence on the fly, consuming significantly less computing power as the data flows through it. However, there is a trade-off. While Mamba is efficient at processing long sequences, it often struggles to maintain precise logical relation part. Mamba offers speed and length, while transformers offer logic and precision. On their own, neither architecture can process massive datasets with high-level reasoning. NVIDIA researchers realized they didn't have to choose one or the other. They combined these concepts into a hybrid architecture called Nemotron 3 Ultra. It is a massive model featuring 550 billion parameters and a context window capable of holding 1 million tokens, the equivalent of several full-length novels. To keep a 550 billion parameter system running efficiently, the model utilizes a technique called mixture of experts. Think of a hospital. You don't see every doctor, you see a specialist. Nemotron works the same way, activating only specific parts of its network. This means out of 550 billion total parameters, only 55 billion are active for any single word. This expert routing is combined with Mamba layers for long-term memory and traditional transformer blocks for logic. The result is a system that maintains high accuracy while scaling to massive document lengths. Nemotron is a machine designed specifically to bypass the mathematical constraints that limited previous generations of AI. Does this mean the era of the transformer has come to an end? Not exactly. Just as a modern computer uses a mix of a CPU, a GPU, and RAM, future AI will likely be a hybrid ecosystem where attention, Mamba, and expert routing work in tandem. By releasing the weights and training recipes for this model, NVIDIA has allowed the broader research community to begin their own experiments with these hybrid designs. The era of simply building larger models is being replaced by a race to build architecturally smarter ones. Tell us in the comments if you think these hybrid systems will become the new standard for all AI. If you want to keep track of how these architectures are being rebuilt, like and subscribe, and I'll see you in the next one.